Okay. Good morning, good afternoon, good evening, everyone. Today, once again, we are back after some break in the month of May. And this month, in the month of June, we like to present the evolving topic. And I think everyone likes to hear about this topic, and it's getting more and more popularity in last couple of years. And there are no prizes for guessing it right because it's all nothing but artificial intelligence. So we will speak about what we are doing in the field of artificial intelligence. And Atharva, the speaker for today, will try to present you some simple practical tips which you can apply it in your research or in your practice. And hopefully that will help you become better in terms of understanding about how this is going to be helping you in your practice or in your kind of career in research and all. So Atharva, to speak about him, he's been with Proton for some time, started as an intern, now he's a research fellow, and he's developing both the back end and the front end part of the Proton, and also quite actively involved in development of AI projects, deployment of the AI projects, and he's seeing the journey through. He also understands the practical challenges, what we face in the Proton, and he will share some of those challenges as we face in day-to-day practice. So sometimes what you see the AI in on your clinic or on the outside, is it like it's like a final recipe served, final food served on your table, but what you don't know is what happened inside the kitchen. So something he will also share what happens inside before an AI product comes to your practice. So welcome once again to all of you for joining and sparing your time. And I'd like to invite Atharva to share his thoughts. And in between, feel free to put questions on the chat bot. We'll be very happy to receive any questions whatsoever as the talk is moving forward. So looking forward for your more interactive sessions and talk from Atharva. Thank you, Atharva, for giving us the talk. Appreciate it.
Thank you so much, sir. So yeah, hello everyone. Welcome to the talk. And yeah, as Sir said, thank you so much for taking the time out of your busy schedules, especially on a Friday on the weekend. So thank you for the opportunity. I'm Atharva. I've done a master's in computer control automation, which is basically robotics and AI from NTU. And I'm currently working as a research fellow under Proton, under the guidance of Dr. Upesh. So this is essentially a workshop on AI literacy, right? As Dr. Upesh mentioned, it is slightly different to the medical and research center talks that we have had in the previous Proton lecture series, but I'm sure you'll all find it useful. I'm sure that many here have heard about AI like almost 20 times a day, right? And you all want to use AI for yourself, but it all sounds very technical and very complicated. So I'm here basically to uncomplicate things for you, right? So I've done my best to keep this talk minimal in terms of the technical aspects of it, but I'll still brush up on some things which I feel will help everyone gain an intuition on how AI works. And when you use it for yourself, you'll get an understanding of what is exactly happening in the background. So let's start. So before we get into the crux of the topic, I think it's important to understand what do you even mean by AI? Like today, it has become very common, like colloquial term to just refer to any chatbots, ChatGPT, Claude, Gemini, everything is just AI, right? Everything is just called AI. All automation tools is just called AI. So it's become a very common word to say AI. But then while that is true, it is true on a surface level sort of thing. So what AI really is runs deeper. And so to understand that, I think it's important to get a feel for what AI has been, like what has been the history of AI, right? Where it began and why it has become such a big deal as it has become today. So it all starts almost back in 1950s, 1960s. Around 1951, there was someone called Christopher Strachey. And Christopher Strachey, basically, he became later the programming research group director of University of Oxford. Uh, but what he did is he made the first checkers game. What you see right now is actually the checkers game that he made. It was the very first, like what everyone agrees that that was like the very first AI code that someone had written. And it was not very complicated. It was not even like a learning tool. All it did is that it knew programmatically that if some move is made, what is the next move, best move for that. And there was a lot of maths involved in it, but it was not what AI is today. It was a different sort of AI back then. But this was done in 1951, so I think credit for that. And in 1952, someone called John Holland designed the first neural networks, the math behind it. But then in the 1990s and 2000s is when classical machine learning became like really popular. It's called the golden era of ML. I think in 1990s is when the first convolution neural network, which is what we use to use on images today, those were designed back then. And in 2004, this is the first time that someone had actually published a paper on using GPUs. Today, we all hear about NVIDIA GPUs, AMD GPUs, and it's all a big thing in AI. It was 2004 when the first paper was published on the concept of using GPUs as an accelerated learning platform for these neural networks that were only mathematical, theoretical thing back then. For the first time, someone started applying it. And by the time 2005, 2006 showed up, people had actually started actually adapting these models on GPUs. And this is what like the classical, let me actually start a laser pointer. So yeah. So these were like the initial mathematical classical machine learning model. In fact, even today, if you go and do a basic course of AI, of machine learning, these are the models you'll first see and first sort of learn. So yeah, that's where it all began. But then in 2012, I think that was the biggest breakthrough in AI is when AlexNet was made. AlexNet was a convolution neural network made for an image challenge. And that paper and that model was the first ever proof that GPU accelerated AIs can actually achieve superhuman accuracy. So that was the first AI actually to beat humans in accurate detection and classification tasks of basic images. So that sort of exploded neural networks. And 2012 is also like the year when the modern AI, what we see today, is actually where it started and where the modern AI boom really began. And this, what you see on the screen, is a basic deep neural network. And we don't have to worry too much about the architecture. We are not here to do too much technical today. But I think it's important to like get a feel of what it looks like. These are what you see here is all numbers stored in matrices. Then in 2017, Google published a paper called Transformers. I'm sure you all have heard of the word ChatGPT and GPT by now. GPT actually stands for Generated Pre-trained Transformers. These transformers were basically AI models that Google came up with, and those models were special. I'll show you why. And these, all of the green, blue, yellow, all of these boxes are actually a bunch of these networks that you see on the left side. It is such a big network. And what they introduced was the idea that the AI can actually pay attention to what its previous input was. So it does something called the attention concept. And that allowed for what the modern chatbots are. ChatGPT is based on this concept. And as a result, in 2022, when ChatGPT was released, it caused this boom of what we see today because ChatGPT 3, which was released in 2022 September or something, was the first time where people were able to see actually these language models able to beat and outperform normal human tasks and some basic chatbots that were there in the past. So there is a lot of AI hype today, right? There's also a lot of talks about AI will replace professionals, right? And the fear of AI that will replace professionals, it's a very valid fear, especially in sectors where you see that simple tasks are being replaced, right, completely by AI tools. But I think it is also important to remember that AI is not an all-powerful system. Right? Today we are trying to intuitively understand how AI works. And the first thing is AI is not a very powerful system. I mean, it is a powerful system, it's not an all-powerful system, right? It is just an autocomplete system, which we are using in a smart way to do the tasks that we are doing today. So in basic colloquial terms, like we're talking about AI, we always say, oh, AI thinks, or AI understands something, or AI knows that this is happening. So all of those are just words we use, but that is in the truest meaning, that's not true. What AI does is it imitates. All it knows is how to imitate human speech that it has learned by reading a lot of data, going through a lot of internet history and all of those things. It has learned to imitate human speech. It doesn't actually know what it's saying. In media, you'll see all of these guys, Google and everyone, they'll show you amazing results. They'll show you use cases, test cases that they've done, which are very beautiful looking, which will feel like, oh, this is going to change the world. But they are very cherry-picked and ideal results. When you actually do it for yourself, you realize that this does not highlight the limitations that you face in real life, such as data quality, especially in the medical sector, right? Data quality, context, the deployment environment, the costs that are there for these models. It's unbelievably high. Like the cost, especially of modern AI tools, is very high. Even though it's accessible, it's still very high. And a lot of these points are never talked about. They're not mentioned in these discussions. Also, all of these vendors that I mentioned, OpenAI, Google, Claude, and all of Anthropic, all of these guys. So while they're doing amazing work, the tech demos only show impressive benchmarks on specific data sets, right? That they have made to show how good their model can be. But the real data, as we discussed just now, differs in demographics, in how you're acquiring the data, how the actual AI processes it, and so many things. So there's always a big difference. So the AI hype, while valid, you should always take it with a pinch of salt. So I think let's brush upon what we are really here for, right? LLMs, that they are the talk of the hour. Everyone wants to know what are LLMs, right? What's exactly ChatGPT? What is Gemini doing? So this is what you see is a very basic overview of what a very brief summary of what LLMs are, and we'll go deeper into it in the following slides. But here I just want to discuss like the basic definition and basic idea, right? So LLMs are a basic, like a foundation model. Not to worry about the meaning of foundation model, but they're like a big AI model that has the ability to understand, generate, and work with natural language. Now you'll say, oh, you just said that understand is not really what AI does. So that's true. Understand is just a word that we're using to say that AI is able to memorize these things and be able to form correlation between words here. It doesn't understand the meaning behind it. It understands correlation between words that appear. And how it works is it basically you give it a lot of data from internet books, all of the research publications that are open source, everything. And it recognizes a pattern in the language and grammar and how you say things. It learns that, oh, if someone is apologizing, you're supposed to say it's okay or, it's fine. So it learns these patterns. And based on that, it generates responses. And like these are the key capabilities of AI. It can generate text, it can answer basic questions based on its knowledge. And because you train it on multiple languages, it's actually able to translate and it's able to summarize what you're saying and all of those things, code generation and all. And why it matters is because up till now, chatbots have been very robotic. If you think back to like 2021, if you think back to I would say pre ChatGPT era, all of those outputs were very robotic. You would not like you would see those chatbots on the website, but the outputs would be very oh, sorry. The outputs would be very weird. Like you could tell there's not a human talking to you. But nowadays, with all of these chatbots, you actually feel a human connect while talking to these chatbots, and that's what has caused this big boom. And there are limitations and use cases that we'll get to. I'll skip it from here for now. Now, before we get into even further of what LLMs are, I'm sure a lot of you have heard of this word tokens, right? I think myself and Dr. Rupesh, when we talk about some AI applications that we're doing with LLMs and all, I think this topic always comes up, oh, we have the tokens which are going to expire, right? Or we don't have enough tokens for this. So what are these tokens, right? I think that's a very important thing to intuitively understand for someone who's not from a technical background. I think it's very important. And the basic idea is very simple. It just is something that breaks down a sentence into simple chunks. So if I say this is a sample text, after tokenizing it basically becomes this is a sample text. So each of these are separate tokens. That's it. So when someone says that the ChatGPT says that, oh, for the first 5 million tokens, we'll charge you $25, something like that, they'll say. That means that when someone is talking to ChatGPT, it is going to look at how many tokens are being used. And for each token, it will charge you whatever money it's charging you. So that's what tokens are. It's nothing some complicated thing. It's literally a word or sentence broken down into smaller chunks. That's all it is. Now, this slide is slightly technical, but I think if you understand this intuitively, I think you will have no worries understanding how LLMs work at all. So I thought it was important to just quickly, briefly go over it. So we just saw earlier that how we break down sentences and words into tokens. Now, let's say we have these four tokens. Let's say our entire AI model is being trained on these four tokens, which is man, woman, king, and queen, right? These four words. This, what you see, right, these numbers is what the AI sees. Now, how do we get these numbers? They're also with an AI model that is trained. But what are these numbers? What do they even mean? So they are usually trained on different or trained to understand subcategories. So for example, if you see living being, the value is pretty high, zero point 0.6, 0 0.7, 0.5, 0.8. So these values sort of imply that all of these words, man, woman, king, queen, imply living beings. Now, feline, you'll say man is very in negative, king negative, queen negative. Woman still has zero point 0.3. That's usually because you refer to some animals in a feminine tone. That's why it'll still show a low value. But yeah, these are all dependent on what text it is trained on. It has probably read some books or some internet articles where it feels that way. So all of these values similarly are like that. For example, you'll see plural, man, woman, king, queen, none of those are plural. They're singular nouns. So you'll see all of them are negative values. Same, it's a noun. So even the verbs are all negative values. Royalty, you'll see man is negative, woman is still point on, but it's a very small value. But king and queen are point 0.9, point 0.8. So it basically learns to understand the categories of behind each word. So it tries to understand what category to put each word into. And then it sort of starts correlating words with each other. That's what LLMs do. So, yeah, so as we said, right, we understood the first part of how LLMs work, which is that we tokenize them. So let's say we have a word myocardial. Now, myocardial infarction, or okay, let's just take the word myocardial. It's a big word. So depending on what chatbot you're using, it'll usually break it down into a word or keep it a single word, depends. But let's say in our case, our use case, let's say that has broken it down to three words, three tokens, myo, card, and ear. Now, what it does is it now tries to predict what will be the next token that will appear. So, like in the previous one we just saw, right? These are different tokens. And this we saw how it creates numbers out of those words and then tries to correlate them. So, it does that correlation to figure out what might be the next possible word. So, look at this example for instance. The word or the sentence is that the patient presents with chest pain, and that's all. That's the input that we have given. Now, the AI's task is to figure out what comes next. So, according to whatever it has been trained on, it thinks that shortness is the most probable next word. Like there are other words also. It thinks diaphoresis is 21% chance of occurring, nausea is 15%. So, all of these words, it has a internal thinking that, oh, this could be the probability of these words. The probabilities again come from the numbers that we saw earlier. But shortness is what it thinks is the highest probability. So it'll put shortness here. It'll say the patient presents with chest pain and shortness. And now it'll take the entire sentence again. And again, it'll try to predict what can come next after the patient presents with chest pain and. So maybe as it goes on, maybe it'll think it is shortness of breath and so on and so forth. But this is how it is working. It is not thinking. Like this is a very important point to note that there is no thinking step here. It is just probabilities. It is trying to guess what the next word could be. So all of the AI that you're talking to, you think, oh, it's talking just like a human with me and all that. It's not doing anything. It is literally trying to predict what is the next best word it can say to you. That's all. So uh, with all of this, I think I want to give a quick demo of how this. I've just been speaking, right? I've been telling you how things look. So I have this QR code. If you want to scan, I'll also keep it open at the end. But I'll go to the link quickly to show you exactly what I'm talking about. Uh, on ChatGPT, I think. Let me go to. Okay, let me just click on this. Oh, it open on the side. Sorry, 1 second. Yeah, no, this one. Yeah. So the QR code, what you saw earlier, will lead you to this. Sorry, is my screen visible? Is the other screen, is it just still the PPT? Can someone confirm?
Yes, it's visible. Atharva, continue.
Okay. You can see the website, right?
Yes, very much.
Okay, okay. Perfect,
Let's
perfect,
continue.
perfect. So, yeah, yes, thank you. So, what you see here is just an animated, someone has made a really cool project which animates and shows us how LLMs look like when they're working. So, we're using this model called Llama 3.2. There are other models available here. And the sentence here is, let's say, who are you? A very basic sentence. Who are you? And when you actually run the AI, see, first of all, it broke it down into tokens. Who are you? Question mark. Four tokens. And then it is predicting that the next best output is I. It still thinks hello, nice, hi, thank, welcome, dear. All of these are small probabilities. These are almost zero. But it has a prediction of that 99.6% chance that I is the next token. So when you run it, it'll put I there. So you see the arrow going there. It has now put I into it. So now what it'll do is that it'll use the who are you question mark I, the whole thing, and try to see what could be next. So now it thinks that I am, like the apostrophe M, is the next best possible thing to predict, next best possible token. So it's trying to say that. It still thinks I am. Again, this is just different because of the font that is treated separately. But I maybe don't, is very small. But yeah, it's things that I am is the best thing to do. So let's say we continue running that. So I am is there. Now again, it'll run the whole thing. It'll think, okay, Anne is it's like 100% almost. It's like very probable that Anne is next. And so it'll keep running. I am an artificial intelligence model known as, so it'll keep going like that. And when it talks to you, this is how it is talking to you. It is just predicting what is the next best word it can say. And you can the ChatGPT and all these models in the background actually have a meter of how strict they want to keep the model and how random they want to keep it. They also have like how slow and fast. This is just animation, sorry. This one, how strict and how open to randomness you want to keep. So let's say I keep it 5, so it's a bit more open to randomness. It'll do this. So you see, it is actually taking less likely words. It is still among the top few, but it's still taking less likely words. So now it will form a sentence that is a bit different. So it'll say, "Who are you? Hello from the future, comma, it." So it is now generating some random this thing. It still forms a coherent sentence because all of the predictions are finally probable because it has seen words being used like that in some websites, articles, books that it has read. So it knows that what it is saying is structurally accurate, but it may not really make sense in the context depending on how random you're letting it be. But yeah, these sort of settings exist inside ChatGPT. They change the settings, and you'll see now it'll be I am okay. Now it is still sticking to the top one. But yeah, that is essentially how these LLMs and these AIs are predicting what to say and how to say it, right? So now I'll go back to this. Let's continue on this thing. Now, LLMs is something that I think I've talked about for a bit, and let's move on to the next big thing that has taken over everything for the last couple of years, maybe. I think 2024 was when agents really became popular, and now it has become like staple. Everyone's using agents. So, what are AI agents, right? You hear about AI agents every day. What are AI agents? So, essentially, all you need to know is this green box. LLMs with tools, that's all they are. They generate text to use tools, they check the output, and they keep trying and then tell the user finally what they learned or what they were able to do with the tools. What are tools? I'll get to that in a bit. But essentially, you need to know that tools are just fixed small codes that do small things. Like there'll be a weather tool that knows how to go to Google, check the weather, come back and tell the LLM this is the weather today. Right? So these are like small tools. They're not AI. They're small fixed codes people have written just to get the weather, just to check the website or check something. Like the small tools. So all agents are is LLMs that have access to these tools. They tell the tools, go find me the weather today. It'll check the weather, come back, tell the LLM today it is 28 degrees Celsius, it's raining a lot in Singapore. And then after the LLM gets the output, it tells the user that, oh, today it's 28 degrees Celsius. It'll put it in a nice way. LLMs will put it in a very nice structured way. Oh, hi, today the weather is this and that and so on. So that is essentially what agentic AI is, right? AI systems that can act autonomously, they can make decisions and coordinate tasks. Now, they're not making decisions out of nowhere. They are still generating text, but we just have a small code that reads the text and like, oh, the LLM is trying to make a decision. Let's run this tool and let's give the LLM what it requires. That's all. It's still the same thing that we have been looking at up till now. So it is in a way better than just using LLMs because if you ask an LLM or like just go to ChatGPT, ChatGPT is a bad example nowadays because it has tools ingrained in it. But in 2002, 2003, if you had asked ChatGPT what is the weather today, it would have no idea. It would just guess something. It'll tell you wrong answers. I know because I've tried it back then. I would put what is some current affairs thing, it would have no idea. So that is, it's good that agents are being implemented now because now the answers given by LLMs are more grounded in truth and more grounded in reality, which makes it better for applications in more difficult or more complex scenarios like healthcare, banking, and so on. So how do these work? Like I just touched over how they really work, but let me give you a quick summary again. So first of all, whatever perception is basically what input you give it. Agents could work from audio, from something that you've typed, from something that it has seen, like you take a photo and give it to the LLM. So in some way, you're giving an input and then the information is processed, right? The information processing is basically to figure out that whether the LLM wants to make a decision, does it want to just tell the tool to do something, which is the decision, or it wants to just generate the output, does it already know the answer to this, and so on. And then it basically tells the tool to do what needs to be done. There's a constant feedback loop, and finally it tells what to do. So that is the basic idea of how agent works. So I'll give an example. Let's say that I have a database which has all of my patient records, patient registry, and I want to know that do I have any patients with diabetes who have come into the clinic within the last 3 weeks? So what the LLM does is it generates instructions for itself to use the tool that looks into the database. So the tool is basically just a normal code that knows how to read the database. That's all. So it will tell the tool, hey, I need to know if there are any diabetes patients. It will first generate the command that requires the tool, that is required by the tool. The tool will go, it will fetch the information, it will come back to the LLM, give it, and then the LLM is like, okay, I see that there are three patients who have come in, or two patients have come in the last 3 weeks. So it'll tell you, hi, I've seen the database, and I think there are two patients who have come in on this and this date. This is the patient ID, and so on. So that's how these agents work. Now, I've been sort of highlighting or slowly talking about the idea that there are limitations to AI. It's not all powerful, all knowing. And these are six topics that I feel are the best summary I can give of what are the limitations of AI. I'll quickly glance through them and I'll not belabor the point too much. But hallucination. I'm sure a lot of you have heard of the concept of hallucination, where LLMs generate outputs that seem plausible. They seem that they're right, but they're not really right. Right? There have been cases genuinely where the LLMs have just fabricated some drugs, drug doses, fake guidelines for things to do. Right? There is no way for an LLM or an AI to check its own answer. It just keeps generating text. That's all it can do. Knowledge cutoff. Now, every AI actually has a cutoff date. This cutoff date is basically for what day, up till what date it has been fed data. So, for example, from the internet, all of the articles that people could find up till September 2023, all of that is fed to the AI, and the AI is trained on that. So, there's a cutoff date of September 2023. And actually, there's a fun trick where you can actually go to these chat GPTs. I'm opening chat GPT here and actually ask them that what is your cut off date. You can actually ask it this question, and it'll tell you my cutoff date is actually 2025. So any information that you want to know that is after August 2025, it will not know it. It is not trained on it. It can still search online, but not know it. So let's say if I ask, can you tell me today's news? Right? You'll see it says searching the web. It doesn't know it itself. It has to search the web to tell you. And then it is giving you all of these outputs, what is happening in the news and all that. So sorry. I'll,
Hi, glad to.
no, yeah, okay. So let's say I ask it, what was happening in January 2025, because this is data that it should know, right? So now you see it did not search the web. I'll stop it here. You did not see it searching the web because it already knew. It has all of that has been trained in it. So that's just a fun way to see how much the AI knows or till where it has been trained. There is no uncertainty signal. As I said, LLMs are very confident in their output. They don't know if they're wrong or right. There is no internal checking mechanism. They just know how to predict the next word, right? So there's no built-in way to identify mistakes. Context window limit. This is a very small issue in the today's context, I would say. But still, like if you want to ask it a question about 10 research articles that you have read, let's say you found some 10 research publications which are very important, very cool, and you want to understand, like, what's happening with them. You want to get a summary of them. If the context window is just limited to two articles, you will miss out everything in the other eight articles. So that's also just to know that it has limits of how much it can process at the same time. Prompt sensitivity, how you're prompting is becomes very important, and causal reasoning. LMs, yeah, I mean, I think I've highlighted this. I'll not talk too much, but yeah, they're correlational models. They don't understand concepts. Okay, so I think now that I have bored everyone with the concepts behind AI and how the technical things work, I think let's move into what you're really here for, using AI in research. And I think the best way for me to start talking about how to use AI best in research is to show something that we have done in Proton ourselves. These are a few of the models that we ourselves have in Proton for segmenting. This one is able to automatically segment the choroid. This one is able to automatically detect the optic disc and the arteries and veins in the fundus image. It is able to get the thicknesses as well of each of the blood vessels at each of the points. This one is able to segment the iris, the lens, the cornea, aqueous region. So all the segmentation is possible. This model is able to segment the retinal layers in the OCT scan, detecting the vitreous haze. And this is actually a artificial image generation project. But then I think you may ask me that although this is very cool, how is it really relevant to you, right? Because we are talking about LLMs and modern AI, modern LLMs have nothing to do with images. And while you are right about that, LLMs are actually much more, how do I put it? They have much more to them than just being able to predict text. And actually, because I'll quickly go back because we looked at this slide. This is why I said this is important to intuitively understand. It's all numbers finally, right? So you can convert images to numbers as well. And that becomes another word that you may have heard, something called vision language models. Where you convert images to numbers, you convert text to numbers, you mix it together and ask the LM to predict what's next. And using that, you can do something like this. You give it an image. That image is then converted into embeddings, what you see here. It's converted into embeddings, all numbers. That goes into the LLM, which itself requires numbers to process. And then it tells you, this is, by the way, a real case where we have an input image, and this is a real output generated by a vision language model which we are using for our testing. So it's basically, it says that this fundus image shows a generally well-illuminated retina, blah, blah, blah. It may not be accurate completely, but it's still able to know that this is a fundus image. It's saying that there's a yellowish lesion. I'm not a medical professional, so I don't know if it counts as a lesion here. But yeah, it's actually able to do this, right? Which is also a very cool thing that you're actually able to feed an image and you're able to make the LLM get you some outputs. So I also want to talk about some AI tools that you can use in your daily life for your productivity and so on, right? I think Notebook LM is a really cool product. I will go to this. Yeah. So Notebook LM looks something like this. It basically is a way for you to upload files, upload things that you are, by the way, allowed to upload. Please upload with care. Do not upload confidential information ever anywhere online. So let's say I want to add some sources, right? Let's say I made this PPT on federated learning. So I'm just going to upload this federated learning PPT. So now you can see it's loading. It is reading the PPT. It is reading all of the text that is there in that. Now, once it is done reading all of it, you can actually start asking it questions about the PPT. Now, there's something there in ChatGPT as well, but it is not as good as Notebook LM, and this lets you upload. Excuse me. This lets you upload a lot of documents, and you're able to actually make your own documents. You're able to make mind maps, reports, overview. You can actually make your own slides and a lot of things. So I have found this very useful in your like self-learning. Like if you are trying to learn a topic, you upload a bunch of resources and you just make your mind maps. You start talking to it. You ask questions. It's a good way to learn in many ways. So you see, like I had made this PPT. It's able to tell me a basic summary of what's happening. So if I say, tell me in 100 words, what is federated learning? I'll ask it this question. So it is retrieving the details from the PPT itself. It is processing everything. It is based on what it is reading. It will define it. By the way, it is also very cool that this AI is actually very strict about only citing from the sources. So you'll see whatever is telling me this, it actually is telling me where it read this. It saw this text in the PPT that I made. It read this in the PPT that I made. So it is actually giving me all the sources from where it is telling me and why it is telling me these things. So it's very good. It sticks to source material. It doesn't try to predict unnecessarily. It'll tell me exactly what it is and where it is learning this and why it is telling me this. So yeah, Notebook LM is a good way to learn. It's a good way to have your own notes and so on. One more tool that I showed in the slides is Perplexity. I think many people are already familiar with Perplexity, but the best thing about Perplexity is that it again sticks to sites. It sticks to citations. It will tell you things only if it has read it somewhere, and it'll prove it to you. It'll show you where it has read it. What. So if I say, what is new in healthcare AI, right? If I ask it that, so it is showing me all these sites. It'll just show me some sites to keep us waiting while it generates the text. And then, yeah, it'll generate the text. You'll see at every paragraph that it creates, it is actually showing you the site from where it read it. For example, all of this is generating, it'll tell you where it read the previous points. This, it read it where. So it is going to cite everything. At the end, you can even click on the sources, it'll show all of the sources that it listed, that it used to list. So it's a good way for like grounded research. I think if you just check it on ChatGPT or something or Google, it becomes sometimes difficult to distinguish between what is being hallucinated and what is actually ground truth. So sites like Notebook LM and Perplexity are a good way to ensure that you have grounded truths. But even then, you should always double check anything that is generated by AI. Always double check that it is true before you cite it anywhere or use the information somewhere or believe the information to be true. No matter, I'm recommending good tools, doesn't matter. You still should always double check. As like, how do you put it? 101 of using ethically using AI. I think Claude, most of you are familiar. I'll skip over it for now. This is a really, really cool thing. It's called Research Rabbit. It's like a one-stop shop for all your research tasks. You can put all your citations in one side. You can start writing your own documents somewhere. It'll keep suggesting things from the citations that you have pulled up, and it's really cool. It's a really good thing. Stitch is actually very nice for designing. If you want to design some slides, you want to design something, Stitch is very, very nice for that. I think I'll skip everything else. Olama is something I do want to show, and I want to also go over why it is so cool. Now, Olama is actually a service that lets you use LLM on your personal computer. Like this is right now running on my computer. I can switch off my internet right now, it'll still run. Nothing that I'm talking with it right now is going to go online onto the internet. It is going to stay here and it is going to run on my computer. The model that you see, I'm running this Gamma 4 model, which is by Google, and is running locally on my system. It is not going online. It downloaded, I think it's like a 20 GB model. I downloaded the whole 20 GB onto my laptop. So now if I say, hello, uh, who are you? So this is actually happening on my computer. It will be a little bit slower because my computer is not the fastest, but it will still be able to take a second and come up with some text. So I'll come back to it when it has predicted something. But yeah, these are some really cool tools which I think are useful and helpful for all researchers, I think. Okay, so the next topic I want to cover, and I think this is like the bread and butter for anyone who's trying to use AI tools today, is called prompt engineering. I think prompt engineering has become very quickly a big topic since ChatGPT came out 2022. And the idea is very simple. So if you ask what is it, it is simply being able to talk to your AI in a way that it gets you the best possible output. So what you see here are some best practices that you should follow. But the idea is you have to be clear and be very specific about what you want. You have to treat the any LLM, any AI that you're using, treat it like an intern that has just joined you, who doesn't understand everything, or rather he understands the topics, he or she, but they don't have field experience. They don't have actual practical knowledge. So treat them like a kid, right? You have to tell them everything, spoon feed everything that you want. You want your AI to make your PPT? You tell it exactly, I wanted 20 slides. I want this. I wanted blue color slides. I want this to be there. I want this slide to talk about that. And you have to be very, very specific. You have to also provide context. So again, I'll stick to an idea. Let's say I was using AI to make the presentation that you see with you right now. I will tell it that, okay, I have to give a talk on AI literacy. What I want you to do is to make a 20 slide PPT, right? I'll be very clear, very specific about what it has to do. It has to make a PPT for me. It has to be 20 slides, right? I will provide context that this is for a healthcare and AI in healthcare talk. So that is the context of it. So any content that it generates will stick to this particular thing, right? Structure your prompt. Like don't put everything in one sentence, right? Try to break it down into multiple sentences. It's okay if you make the prompt into 20 sentences, right? That's totally fine, but structure it well. Iterate and refine. You give one prompt, it'll probably not give you the best output. It's okay. You look at what it did wrong and make a better prompt, and then again do it. It'll do a better job. And it's a iterative process. And at the end of it, after maybe 1 hour of trying this, you will be left with a very beautiful prompt that you can use anywhere for the similar task. Right? I do that often. I have a few set of prompts that I use for fixed tasks. So yeah, be mindful of limitations. Okay, I skipped this. Let me come to that first. Specify the output. You have to tell it that I want a PPT. If the AI cannot make a PPT, then give me the content for a PPT. Structure it in one paragraph such that you have point number one and all the content that goes into slide one. Point two, all the content that goes into slide two, and so on. You have to spoon feed what exactly do you want from it. Be mindful of the limitation that models will make mistakes. Do not blindly accept whatever it gives you. Double check what it is telling you. Don't assume that any facts that it has put into the slide is going to be accurate, right? Just be mindful of that. Keep it ethical and safe. Do not upload things which are going to violate privacy policies or whatever. You have to use it responsibly. And the best thing I think a lot of people skip out is give examples. Say that, okay, this is a PPT that I made last year for another talk, which is on similar topic. Use it, look at it, and then make the PPT. So this is a basic thing. And honestly, I know this is a bit overwhelming. Like I'm asking you to keep all of this in mind in the 2 minute talk. But the best thing that I do, and I think anyone can do this, and it is the best thing to do. If you are stuck and you're not sure what is the best prompt to give, don't worry. The quick hack is if you're not sure how to structure a prompt, just ask the AI. Tell the AI, I want to make a PPT. It has to be 20 slides. It has to be on this topic. Just that much. 20 slides, the topic, and I want to make a PPT. And tell it, give me a prompt that I can give back to you, which will help you make the best possible slides. And sometimes the AI will ask you questions. Okay, let's do this. Tell me about this. Do you want this? Do you want that? And it'll ask you some questions. You answer the questions, and it'll itself create a prompt that you copy paste into itself and it'll generate an amazing output. And this works. This always works. So if any time you think that, oh, Atharva has taught us so many things, it's too much, all of these prompts make no sense, don't worry. Use this hack. Trust me, it works 9 times out of 10. Now, I think this is the most important thing, the safe use of AI tools for researchers, right? Especially in the field of research. There have been cases recently where people talk about research publications, like genuine research publications that have gone to be on big journals and that have clearly AI generated content in them, right? Clearly the sentences, the figures, they're all AI generated. And that's not good, right? Because what happens is if the AI is hallucinating something, and after hallucinating it comes up with a fact which doesn't really exist, but then someone else puts it blindly into a research paper, and the research paper actually gets published. And then because this hallucinated false information is now published, is the public information published material, other AI tools are going to think, oh, that is a fact. I just saw it in a paper published by a human. That means it must be true. So it is going to come back and tell you, yep, this is true. I read it in the paper. And you will also read and think, oh, someone's written this must be true. They have done this research. So what happens is it creates a loop of endless false information that has already started happening. Like this is not just a warning for the future. This is already happening, and we need to be very careful about checking these things when we're using it for research, right? Now, I just gave an overview of the biggest problem with that, but let's talk about some do's and don'ts, right? Use AI for ideation and drafting, but rewrite in your own words. Don't actually use AI to write your paper for you, right? Summarize the literature with caution because, yeah, some literature review, it is helpful to have 20 papers summarized by AI for you, but then double check, is it really saying what I think it's saying? Is it really saying that from this literature, right? Give context as much as possible. Like this is just a good habit. It's not like preventing any problems, but be specific about exactly what you want from it. Verify every claim. I think I've said this quite a lot today. Verify everything that AI says, and use tools that are actually approved by institution. A lot of these institutions, a lot of hospitals, and a lot of research centers have their own like internal bodies that check which AI to use. And if an institute doesn't have, there are a lot of online resources where people actually double check is this good for institutional use. I think it's a good idea to start there. And do not enter any sort of data that is private, anything that may risk public data being released, right? Do not trust AI generated citations. Make sure that the citations are true, right? Double check it against the DOIs and everything. Use AI as a statistical authority, right? Like if you think that, oh, AI is saying that this is 95% true, don't use it. I mean, okay, this is used, but it's undertones. Don't assume that it is right on that. Like always double check. Do not submit unedited AI written text. I think I just explained why not, right? Let AI agents act on the oversight, the same reason. Don't let it write the paper for you or post it to someone, email it. It can make mistakes. Make sure there's always a human in the loop, right? So the golden rule, as I think I mentioned this earlier in different words, but AI is a research assistant. It is not a co-author. It is not a data custodian. It is not an ethics board, right? Your judgment is what matters. All of this AI generated content is to supplement you. It is not there to replace you. That's the main idea. So humans and AI co-working is what is really required, right? AI tools are there to help you. Like I think I always use this analogy that AI tools which are there, they are like a scientific calculator. They don't replace a mathematician, but it makes the mathematician's job really fast because he doesn't have to do or she doesn't have to do all the calculations. You just focus on the important creative aspects of it. So yeah, I think I've covered these topics. I'll not read each and one of them for you, but that is the general idea, right? And as I think Dr. Rupesh mentioned earlier, AI will have problems. I highlighted some of the problems just now. There are problems that come when you actually try to make your own AI models, which are to do with data acquisition. I spoke about that earlier, which are to do with deployment actually in the servers, the costs that come with it. So a lot of issues with it. But AI can be a really, really powerful tool, a really helpful system that can make your life, make your day very productive. So use it, but use it with care. That's the bottom line of it. So I think that concludes my talk for today. Thank you for patiently listening to everything. Is there any questions?
So, Atharva, it was a very wonderful talk and I really enjoyed it. I'm sure everyone else would have enjoyed. Let's open it up for the rest of the audience. Anyone, any inputs or any specific use case you've been using it and you stumble upon a problem and or you want to kind of go through some of these used cases or examples which Atharva has shown. Anyone can switch on the microphone and switch on the video and just please speak up. Please. If not, then I have certain questions. So, Atharva, while this is coming up, you spoke about what are the legal aspects of it as you speak about, because you will have patient using it, you will have doctor using it, you will have everyone else using it. What are the legal implications of using the LLM by different people and they getting a lot of information?
Yeah, absolutely. I think legal implications of AI can be broken down into two aspects because one aspect is your own moral and ethical ambiguity there. As in, you are using AI to create and generate content that may or may not really exist, or you're using AI to actually read patient information, you're reading uh, information that you're not authorized to access. That is one aspect. The other is a lot of countries and a lot of institutions are coming up with legally binding rules about using these things. There are a lot of tools that are there to catch you in the act. A lot of people are making tools that can catch AI in papers and all of these things. So the biggest legal implication is that one, you are accessing data that you're not supposed to access, and that is morally, ethically, and legally incorrect, as well as the fact that you are actually circulating information that is untrue, and that also violates a lot of legal laws in terms of misinformation spreading, right? So there are a lot of legal, it's difficult to bind AI in legality, but then there are a lot of frameworks coming into play, and it is slowly becoming more complex to deal with that.
Okay, so good. I just wanted to highlight a few other points as you've been going to use AI, and a lot of AI is going to use. So make sure that whenever you use AI for whether it is like writing literature or whether it is reviewing literature or anything like that, please do mention about the use of AI. Don't try and hide it because it's quite means everyone is like everyone will be aware and so better to declare it and disclose it so that everyone is on the same page and then they know number one. Number two, also while we use AI, make sure that you are reading it, you understand what's the output of it and understand that, and before you say it's no harm using it, but it's very important that you understand and you approve it every time general asks, so you approve it if you are going to use it. uh, Again, there will be certain limitations which will be there. Try and understand as much as you can. Yeah, and yeah, then we'll see. Okay, any other question?
Feel free, like any, even the most basic questions or even the most complex questions, if you have anything, feel free. Or if you don't want to talk now, you can message me later also. Okay.
Looks like everyone understood Atharva.
Yeah. Yeah.
Everyone is expert now.
Yes. I'm glad everyone's now an expert in AI. So hopefully in Proton also we'll see everyone expertly using AI.
Hmm. Okay. Okay, then. Thanks, Atharva, for your wonderful talk. We really enjoyed it. Thank you. Thank you.
Thanks so much.
Thank you, Atharva.